Hello and welcome to the last video in this series on Surds, and we're going to round off everything that we've learnt so far and do some problem solving questions. So lots of these type of questions will come up in your GCSE papers, and it will be in the higher paper, and the grades you're looking at are roughly 7 to 9. So the slightly easier Surd questions will be a grade 7 or might even dip into the grade 6, and then the really tricky ones can go all the way up to grade 9. Now, most of these questions will be on the non-calculator paper. I'm not saying that there won't be any on the calculator paper, but usually Surds is a non-calculator skill. But I'll tell you at the beginning of each question whether it's calculator or not. So for all of these questions, I encourage you to pause the video first and give them a go yourself. So this first question is a non-calculator question. So a shed has dimensions in meters of height √5, width √6 and length √10. We need to find the volume of the shed and give your answer as a simplified surd. So whenever we're asked questions on measurements, I always like to draw out a sketch. So let's do a sketch of a cuboid representing the shed. So this is obviously not going to be the best drawing in the world, but hopefully you get the idea. So this is my shed. The height is √5. The width is √6 and the length is √10, and we need to calculate the volume. So to calculate the volume of any cuboid, we just need to multiply all of the dimensions together. So we're going to have √5 multiplied by √6 multiplied by √10. Now we need to evaluate this and give our answer as a simplified surd. So the easiest way I can think of doing this is, first of all, if we simplify all of these surds, well, they are all already simplified. However, we can split these surds up. Let me just show you what I mean. So √5, we can leave that as √5 times, now instead of writing √6 is the same as √3 times √2. Okay, using our surd properties, √6 is exactly the same as √3 times √2. So I'm going to write that. So √3 times √2. And then if we do the same with √10, I know that the square root of 10 is the same as √5 times √2. So we're just going to multiply it by √5 times √2. And the reason I'm doing all this is because we do get a lot of things that simplify. So if I just, let's just do this in green. Hopefully you can see that we've got √5 times √5. Well, that's just going to give us 5. And then if we do the same, let's use magenta. So we've got √2 times √2. Well, that's just going to be 2. So it's going to be 5 times 2. And then we've just got this √3. So times √3. So what does this give us? Well, 5 times 2 is 10. And then if we times by √3, well, that's just 10 √3. So our answer is 10 √3. And we're not given any sort of units, I should say. So we could just leave our answer as 10 √3, and I'm just going to write in here units cubed. Okay, because we're not told what the units are, but what they're looking for is the surd, so that is the answer, 10 √3. Okay, the next question. The midpoints of the sides of a square of 16 centimetres, which is this square here, are joined to form another square. This process is then repeated to create the shaded square. Find the area of the shaded square. So first of all, we're starting off with a square that is 16 centimetres by 16 centimetres. And then we're told that the midpoints, so these are midpoints of the square, are joined to form another square. So first of all, let's calculate the length of each of these the side length for this square. So we know that these are the midpoints. So if I just take one of the triangles, so I'm just going to do a slightly, that's not very good drawing. So let's take one of these triangles. We can see that this is a right angle, and we know that this length here is 8 centimetres because it's half of the square. So this is 8 and this is 8. So using Pythagoras, we can calculate the hypotenuse. Let's just call that x. So we know that x squared, using Pythagoras' theorem, is equal to 8 squared plus 8 squared. And I've just realised that I forgot to say whether this is calculator or non-calculator. So this question is a non-calculator question. So let's calculate this. So x squared is going to equal, well, 8 squared is 64. So this is 64 plus 64. So what is 64 plus 64? Well, that is 128. But remember, this length isn't 128. That's this length squared. So we need to square root our answer. So x is going to equal the square root of 128. Now, we don't have a calculator. Now, but I can see that this here is 2 lots of 64. Okay, it's just 64 plus 64. So it's equal to the square root of 64 times 2, which is equal to the square root of 64 times the square root of 2. And the square root of 64, well, 64 is a perfect square. This is 8. So this is just 8 root 2. So I've just basically simplified root 128 to 8 root 2. So now we've calculated this length, what we can do is just repeat the process to find the dimensions of this square. So if I just highlight these points here, okay, we can calculate this length here because we know this length, because this point here is halfway between these 2 points. So if I just draw this triangle in now, so this is my new triangle, and this is obviously a right angle because it's part of a square. So that's a right angle. Now this length here is this length, and you can see that it is half the total distance, which we just found out. So it's half of 8 root 2. So what is half of 8 root 2? Well, that's just 4 root 2. If we do 8 root 2 divided by 2, well, that just gives us 4 root 2. So our shorter lengths are 4 root 2. So this is also 4 root 2. And we need to calculate this length here, which is the hypotenuse. So I'll just put an arrow. We're calculating this length here. Let's just call that x again. Actually, instead of x, just to hopefully not confuse you, let's use y because we've already calculated x. So using Pythagoras again, we can say that y squared is equal to 4 root 2, all of that squared, plus 4 root 2, all of that squared. We're just squaring each of the shorter lengths. So what is 4 root 2 squared? Well, 4 squared is 16. Root 2 squared is just 2. 16 times 2 is 32. So it's going to be 32. All of this is 32. And this is going to be the same. This is going to be another 32. So y squared is going to be 32 plus 32, which is 64. And then we square root both sides. We get y is equal to, it's just 8, not minus 8, because it can't have a negative length. So y is just going to be equal to 8. And that is that's not our final answer, because we're asked to find the area of the shaded square. But we know that this length is 8. So the area, let's do it in a different colour just to finish it off. So our area is going to be 8 squared, which is 64. And we're told the units are in centimetres, so it's going to be 64 centimetres squared. And that is our final answer. Okay, the area of a rectangle is root 125 centimetres squared. The length of the rectangle is 2 plus root 5 centimetres. Calculate the width of the rectangle. Express your answer in the form a plus b root 5, where a and b are integers. Okay, the first thing I'm going to do, as before, is to draw a sketch of our rectangle. So let's draw it out over here. So this is my rectangle. So let's just pretend that these are straight lines. So we know that the area is root 125, square root of 125. The length of the rectangle is 2 plus root 5. And we need to calculate the width of the rectangle. So let's just call that x. So we need to calculate the width of the rectangle, and then when we've done that, our answer should be in the form of a plus b root 5, where a and b are integers. So we know how to calculate the area of a rectangle. We know that it's width times length. So let's write that out. So the width is x, and if we multiply that by our length, 2 plus root 5, that will give us the area of the rectangle, which is root 125. Now, I'm just going to pause because at the moment, this is not in its simplest form. So root 125, we can simplify that. 125 is the same as 25 times 5. So this is the same as the square root of 25 times the square root of 5. And 25 is a perfect square. So the square root of 25 is 5. So this is just 5 root 5. So always try and simplify your surds if possible when you're doing these type of calculations, because instead of dealing with 125, now you're just dealing with 5s. So it just makes future calculations a lot easier. So all of this is going to equal 5 root 5. Now we've got an equation here with x. We need to calculate x. At the moment, we are multiplying by all of this. So to get x on its own, we can just divide by this expression. So let's do another line of working. We're going to have x is equal to 5 root 5, all of that over 2 plus root 5. So we have found the value, or we have found x, we found the width, but it's definitely not in this form. So we need to put it in this form. So we need to get rid of this fraction, or this denominator, I should say. Now, to get rid of a denominator that has a surd in, we can rationalise it. So if you're a bit unsure of how to rationalise the denominator of a fraction, I encourage you to go back and watch my video on this topic. I think I'll leave a link in the top here. It'll either be in the left or right. I'm not sure where YouTube puts them, but I'll leave a link for that particular video. So to rationalise the denominator, we need to multiply this fraction by 1, but instead of writing 1, let me just do this in a different colour. I'm going to multiply it by 2 minus root 5 over 2 minus root 5. Because essentially this is just 1. So we're not changing the value of the fraction. But if we do this, it will eliminate the surd in the denominator. Hopefully we'll see this in a moment when I multiply it out. So let's do another line. So in the numerator, well, we've got 5 root 5 multiplied by 2 minus root 5. And in our denominator, I'm just going to write the whole thing out. So we've got 2 plus root 5 times 2 minus root 5. So let's just write equals here. Let's do the numerator first. So 5 root 5 times 2, well, that's 10 root 5. We've got 10 root 5 minus, and then 5 root 5 times root 5. Well, the root 5s will just cancel. Well, they won't cancel, but root 5 times root 5 is just 5. And then if we multiply that by 5, we get 25. So that is 25. And then now if we focus on our denominator, so let's use FOIL for this. So let's do the first terms. 2 times 2, that's nice and easy. That's 4. Now do the outside terms. So we've got 2 times minus root 5. Well, that's minus 2 root 5. And then these middle terms will be plus 2 root 5. And then the outside terms, root 5 times root 5 is just 5. And it's going to be negative. So minus 5. Okay. So the numerator, we can't simplify the numerator. So that's still 10 root 5 minus 25. But the denominator, we should be able to simplify. And we can see, or hopefully you can see, that the middle terms will cancel out with each other. Negative 2 root 5 plus 2 root 5 is 0. So those two terms cancel out, and all we're left with is 4 minus 5, which is negative 1. So we're almost done now. So 10 root 5 divided by negative 1, well, that's minus 10 root 5. And then negative 25 divided by negative 1, well, that's plus 25. So we've almost got it in the right form. We just need to switch the two numbers around. So our final expression for our width will be 25 minus 10 root 5. And let's just check to see if we've got it in the form that they're asking for. So it needs to be in the form a plus b root 5, where a and b are integers. Well, a is going to be 25. A is just the constant, sort of just the integer. So a is 25. And b, well, that's going to be the coefficient on the root 5 term, which is negative 10. So we've got our expression here, and we can say what our a's and b's are. A is 25 and b is negative 10. Okay, the next question. The triangle below has an area of 2 root 6 centimeters squared. Find the height of the triangle. Give your answer as a simplified surd. So let's just see what we've got so far. So the area, let's write the area inside our triangle. That is 2 root 6. We know the base of our triangle. We need to calculate the height. Now, how do we calculate the area of a triangle? Well, it's half base times height. Let's just write that. So let's write the formula down. So area is half times the base times the height. Well, we know what the area is. The area is 2 root 6. So it's going to be 2 root 6 is equal to a half times the base, which is root 12. Root 12 times the height, which is x. That's what we want to work out. So first of all, let's just get rid of this half we've got on here, because at the end we just want x on its own. So if we multiply both sides by 2, I'm just going to write what we're doing here. So if we multiply both sides by 2, what are we left with? Well, on the left hand side, 2 root 6 times 2, well that's just 4 root 6. So we've got 4 root 6 is equal to root 12x. Okay, there's a few things we could do here. What I'm going to do is I'm going to get x on its own. So at the moment we're multiplying by root 12. So if I divide both sides by root 12, we'll just have x on its own. So if I divide the left by root 12 and I divide the right by root 12. So on the left hand side we've got 4 root 6 over root 12. And on the right hand side we've just got x. So we have found the height of our triangle, but it is definitely not a simplified surd. So we need to simplify this. So to get rid of our surd in the denominator, I'm going to square both sides, because if I square root 12, that will just get rid of the surd. So if I square the left and then square the right, that's absolutely fine. I'm doing the same to both sides. So if I square the numerator, we need to square everything in the numerator. So 4 squared, well that is 16, times square root of 6 squared, well that's just 6. And then in our denominator, root 12 squared, well that's just 12. And then on the right hand side, we've got x squared. Now we can tidy this up. 16 times 6 is 96. So I'm just going to come over here now. So we've got 96 over 12 is equal to x squared. And 96 divided by 12, that divides very nicely indeed. 96 is in the 12 times table. It goes 8 times. So this fraction here is just 8. So we've got 8 is equal to x squared. So x is just going to be the square root of 8. So I'll keep the x's on the right hand side. So x is equal to root 8. But be careful, this is not fully simplified. We can simplify this. The square root of 8 is the same as 2 root 2. And just to show you that, root 8 is the same as root 4 times root 2, which is x. And the square root of 4 is 2. So our final answer, let's just do this in blue just so it stands out a bit. So our final answer is going to be x is equal to 2, which is where this comes from the root 4, to root 2. So that is our final answer. And it is in centimetres, so let's just tag on the end there, centimetres. Okay, this is the last question on this video. Show that the fraction 2 over 1 over root 3 plus 1 can be written as 3 minus root 3. So this fraction looks quite complicated, so let's just deal with it in stages. So let's focus on the denominator. We've got 1 over root 3. The first thing I'm going to do is rationalise the denominator. So let's do that. So we've got 1 over root 3. So to rationalise this, I can just multiply by root 3 over root 3. So again, we're just multiplying by 1, so we're not changing the value of the expression. But when we do this, it will eliminate the surd in the denominator. So 1 times root 3, well that's just root 3. Root 3 times root 3 is 3. So now, instead of writing 1 over root 3, we can just replace this. Let me just circle it. We can replace that with root 3 over 3, sorry. So now let's focus on the whole of the denominator. So I'm just going to box that in red. I'm just going to write this out. So we, instead of 1 over root 3, now we've got root 3 over 3 plus 1. So how do we add these two numbers together? Well, we need a common denominator. So instead of writing 1, we can just write 3 over 3. So 1 is the same as 3 over 3. And now we have the same denominator, we can add these fractions together. So these two fractions, if we add the numerators together, it's going to be root 3 plus 3, and then all of that over 3. So now let's write our whole fraction. So we've got 2 in, let's just move along a bit further. So we've got 2 in the numerator, and in the denominator, we've got root 3 plus 3, all of that over 3. Now, whenever we're dividing by a fraction, that is the same as multiplying by the reciprocal of that fraction. So that's one of those skills that you learn a bit earlier on. So instead of dividing, we can multiply it by the reciprocal. So we've got 2. Instead of dividing, we're going to multiply by this fraction flipped upside down. So we've got 3 in the numerator, and in the denominator, we've got root 3 plus 3. So if we just multiply across, well, it's just going to be 2 times 3, which is going to be 6. So you've got 6 over root 3 plus 3. So we're getting there slowly, but notice again, we've got a surd in the denominator. We need to get rid of that, so we need to rationalize this denominator. So let's do it over here. So we've got 6 over root 3 plus 3. And to rationalize, I'm going to multiply by root 3 minus 3 over root 3 minus 3. So let's focus on the numerator first. So 6 times root 3, well, that's just 6 root 3. And then 6 times 3 is 18. So we've got 6 root 3 minus 18 in the numerator. And then in the denominator, I'm just going to multiply everything, just so I don't skip any steps. Root 3 times root 3 is 3. Root 3 times negative 3 is negative 3 root 3. 3 times root 3 is positive 3 root 3. And then 3 times negative 3 is negative 9. And now we can just tidy this denominator up. So the middle two terms will just cancel out. So all we're left with is 3 minus 9, which is negative 6. So I'm just going to do a new line just to keep all my workings. So we've got 6 root 3 minus 18 in the numerator. And in the denominator, 3 minus 9 is negative 6. So we're almost there. We just need to tidy this up. So 6 root 3 divided by negative 6. Well, that's negative root 3. And then negative 18 divided by negative 6 is positive 3. So notice we have the same value here, but it's just the other way around. So let's just switch the terms around just so it's identical to what it's being asked for. So we have 3 minus root 3, and we compare that with what they are asking for. It is identical, so we know we are spot on with our answer. Okay, so this was the last video in this series on surds. So if you have missed anything, please go back to my surds playlist and watch those videos. So hopefully you've had as much fun doing these as I have. And I look forward to seeing you in the next video. Take care.